Well, good morning, calculus. This is our first lesson on integrations, which is the same thing as finding the antiderivative. We're going to find a definite interval, and this goes over an interval of space, and we're going to use it to approximate the area under a curve. You'll have two options. You'll either underestimate it or you'll overestimate it. And I think that's pretty well self-explanatory. So when we find our antiderivative, or our area under the curve, we start with a very simple curve. In this case, we have y equals x squared, and we're doing an interval from 0 to 4. So if you notice here, I have 0 to 4, and this line right here represents the curve y equals x squared, where it crosses here at 2, 4, 3, 9, and then 4, 16. What I need to do is I need to take these four rectangles that I can easily find the area of, add them together, and that will give me right area using right endpoints. And if you look, if I graphed here, here's my 1, 2, 3, 4. I made this box, I started from the right side, and it went up to this point 1, 1, and I just made the rectangle. So when I went over here at 2, this is 2, 4, and I made my rectangle. Now in each case, the width of the rectangle is 1 unit. The heights just change. So when I would find the area of this, well, it's 1 by 1, so its area would be 1. This one is 1 by 4, because that's the y value at this point, it's 4 units up. This one is 1 by 9, and the last one is 1 by 16. And I add those up, and I get an area of 30. Now, if you notice, these are outside of the curve. They're not underneath. So this will end up being an overestimate when I get done. All right, then we want to use left endpoints. Notice it is the same curve. It's the same from 0 to 4, except this time when I started it, I used the left side. So I'm going to start with this rectangle. If I go up here, this is the point 3, 9. So the height of this one is 9. The width is still 1. So the area of that piece is 9. Again, I use the left side. I go up. So this is the point 2, 4. So the height there is 4. The width is still 1. Here's my point 1, 1. So the height is 1. The width is 1. So I have an area of 1. But this last one has no height. Now, we add those together. We get an area of 14. Notice these boxes are not included. So this will eventually be an underestimate. And then the last one we want to look at asks us to use the midpoint. So my graph is exactly the same. I still have my points 0 to 4, but when I determine this height, I base it on the midpoint. So the midpoint between 0 and 1 is a half, so the height here would be a fourth. Here, the midpoint would be 3 halves, so the height here would be 9 fourths. The midpoint here is 2 1/2 or 5 halves, so this height would be 25 fourths. And the last one between 3 and 4 would be 3 1/2 or 7 halves, so the height here would be 49 fourths. And if you notice, I left them all in fourths, I added them all together, and I get 21. Now if you look at it, I have less leftover space than I did on when I used the left side. I still is going to be an underestimate. But eventually, we're going to make these intervals so they're closer and closer together. So what we're striving for now is just the very low level. We're going to be dealing with very simple boxes that we find the area and we add them together. Now, we could get a better accuracy if we change the width here to a half, or to a fourth, or to a sixth, or a tenth. So the smaller we would make the interval here, the better off our area under the curve would work out to be. All right, so we're going to have definite intervals. In our case, we showed the 0 to 4. We're trying to approximate that area of the curve. You have to tell whether your area is underestimated or overestimated. All right, that's the basic lesson. So now I want to look at number 3, and that's the first one on your homework, and the steps that you have to do. There are 4 parts of each of these first problems. If you look at the instructions on page 304, it says find the finite approximation to estimate the area under the curve. A lower sum with 2 rectangles. B, a lower sum with 4 rectangles. C, an upper sum with 2 rectangles. And D, an upper sum with 4 rectangles. In our particular case, our function is f of x equals 1 over x. And we're going from x equals 1 to x equals 5. Now, if you go back and you look, this is an under one. So when they talk about an under, we're going to use either midpoints, and in my case, I'm going to use left endpoints. So when I do A and B, I'm going to do left endpoints. And then when I do C and D, I'm going to do right endpoints because they're going to be over. All right, so I'm going to need a fairly accurate graph. And that's basically all I've done. Eventually I'll show you how to do this with a spreadsheet, but for right now we can just do it this way. So if I would put 1 into my curve, I would be at 1. If I would put 2 in here, I would be at a half, then a third, a fourth, and a fifth. And you see it's very small. So what I'm going to do, just to make my life a little bit easier, I'm going to change, and I'm going to call this 1. So here I'm at the point 1, 1. Here's 2, 1/2. 3, 1/3, 4, 1/4, and 5, 1/5. So if I drew the curve in, oops, kind of missed that last one. This is the type of arrangement that I would have. Now, we said we're going to use left, and we want 2 rectangles. So since we're going from 1 to 5, we know that our rectangle would each be 2 units wide. So we would draw the rectangle. So if they ask, this would be A. We use left, and we have 2 rectangles. So we need to find the area of each of these boxes, add them together. So in this case, in the first box, we have 2 units by the height of right to here. Well, if this point is 3, this is 3, 1/3, and this point is 5, 1/5. So this vertical piece right here is 1/3 tall. The width is 2, so the area of this first box will be 2 times 1/3. In the second box, the width is still 2, but the height in this case is 1/5. So we need to take 2/3 plus 2/5. We'll change them to 15s. If one of these is wrong, that one's right. So we're going to get 16/15 is our area, and it is an under. Now, when you would do part B, and I'm not going to put it here because it's going to make this very wild, you have 4 rectangles. So in other words, you're going to have, here's your first one, then here up to here will be your second one, then your third one, and then your fourth one. Find the areas of each of those, just like I did, add them up, and you'll have the area for part B with 4 rectangles. Now, if I would go to part C, again, I need to have my graph. And I'm making this 1. And my curve goes 1, 1, 2 1/2, 3 1/3, 4 1/4, and 5 1/5. Now, when they say I have to use the over, and I need 2 rectangles, I'm going to start here on the right side, or the left side. Oops, gotta miss that one. And then right here. So for each of these boxes, the width of this box is 2 units, just like the width is here is 2 units. But the height is going to change. Here, the height is 1, 1, so the height of this box is 1 unit, so we'll take 2 times 1. Here, our height goes to this point, which is 3 1/3, so the height here is 1/3, so we'll have 2 times 1/3, so we'll have 2 2/3 would be the area that's overestimated. Now, if you look at the other one, 16/15 was under because we had a lot of white space not included. Here we have over, so the actual area on the curve is somewhere between 16/15 and 2 2/3. What you're going to do at the homework for each one of these, and I just want you to draw them on your paper, make sure you have a scale. I need to see your rectangles for each one of them that you do. All right. Friday in class, we'll go over this again, and I'll show you how to use the spreadsheet cards. Good luck.